Okay, question 9, given m of x is equal to x cubed plus ax squared plus bx and p of x is equal to x plus 1. So we're given a cubic graph there and a straight line graph. C and D, 3, negative 54, are the turning points of our cubic graph M. The graph of M passes through the origin, 9.1, show that A is equal to 0 and B is equal to 27. Now usually when they're asking us to solve for two variables, we use simultaneous equations. So let's set up our two equations. The first equation we use is the derivative of M, because they gave us the turning point, one of the turning points of M. So let's find the derivative of M. So M prime x will equal to 3x squared plus 2ax plus b as it stands. And into this derivative, we substitute the x value of the turning point only. So we'll end up with m prime at 3 into 3, equals 3 into 3 squared plus 2a into 3 plus b. Open out all your brackets and equate to 0. So 0 is equal to 27 plus 6a plus b. Take your constants onto one side. So 6a plus b is equal to negative 27, and that's our first equation. We can set up our second equation using the point D as a point on the graph. So we'll take the m of x equation again, and into this m of x equation we'll substitute the point that lies on the graph, which is D. So we'll substitute 3 and negative 54 into that original m of x equation. Wherever we see x, we'll put 3, and wherever we see y, we'll put negative 54. So negative 54 then will equal to 3 cubed plus a into 3 squared plus b into 3. Simplify all of that, and eventually you will come to negative 81 is equal to 9a plus 3b. So we have two equations here. We just need a third one, a simple one, to substitute into the other. So we'll go with equation 1 and we'll solve for b in equation 1. So b will equal to negative 6a minus 27, and that will be equation 3. So in my next step, I'll substitute equation 3 into equation 2, which means that in equation 2, wherever I see b, I will substitute negative 6a minus 27, which is what I've done here. Okay, so open all of that out, and you'll end up with a is equal to 0, and answer that we needed. You take that a is equal to 0, substitute it into equation 3. You'll end up with b is equal to negative 6 into 0 minus 27. And solve that, you'll end up with b is equal to negative 27, the other answer that we needed. 9.2 now. Calculate the average gradient of m between C and D if it is given that x is equal to negative 3 at C. So for average gradient, I use 2 points, and I use the normal gradient formula to work this out. So my coordinate at D was given to me in full, which was 3 and negative 54, but my coordinate at C was not given in full. I just have the x value given as negative 3. So I need to calculate the y value there for my C coordinate. I do this by taking the negative 3 given to me, substituting that into the original equation that I have now for m, and I'll get a y answer of 54. So my coordinate at C stands at negative 3 and 54, x1, y1, x2, y2, and I use my average gradient formula, y2 minus y1 over x2 minus x1. Substitute all of that, and my average gradient will work out to be negative 18. 9.3. Show that the concavity of M changes at x is equal to. Right, so when we talk about concavity, we're looking to find the second difference. Okay, and we equate the second difference to 0, and we solve for x. So we have our m of x equation, which is equal to x cubed minus 27x. We find our first derivative, that is 3x squared minus 27. We find our second derivative from that, that is 6x. We take the 6x, equate to 0, and solve for x. X will equal to 0 there. So the concavity changes at x is equal to 0. Okay, 9.4, what does this answer mean? At x is equal to 0, which is the point of inflection, the concavity of the graph changes from concave down to concave up. As per my little diagram there, you can see that at the point of inflection there, the graph does actually change from being concave down, and it does change after that point of inflection to being concave up. 9.5. Determine the value of x where x is less than 0, at which the tangent to m is parallel to p. Now, the word parallel there should immediately take your mind to gradient, because parallel lines have equal gradients. So if we're talking about a tangent is a straight line graph. Y is equal to mx plus c, and parallel means the gradients would be the same. So p of x now, the gradient is 1 from the equation that they gave us for p. M of x is equal to x cubed minus 27x. We find the derivative of m of x. M prime x will equal to 3x squared minus 27. But this derivative, another word for derivative is gradient. So the gradients are the same, so we make our derivative equal to the same gradient of p. So it becomes 3x squared minus 27 is equal to 1. We solve this now for x. 3x squared is equal to 1 plus 27, which is 28. X squared is equal to 28 over 3. X is equal to then plus minus the square root of 28 over 3. You end up with x is equal to 3,06, or x is equal to negative 3,06. But the question clearly says that x must be less than 0. So our final answer there will be x is equal to negative 3,06.